Okay, if you remember a little while back, you read this article, Where Have All the Bees Gone? And the point of reading this article and answering the questions was not only to learn a little bit about where the bees have gone, but also I was pre-assessing you on how well you were able to answer text-dependent questions. You had 10 questions to answer after reading the article. And what I noticed was that when you turned these in, many of you turned in the article looking exactly the way it did when you received it. So there was really no marking up of text. I didn't see any notes and margins, things like that. No marking up of questions, underlining, circling things. So this lesson today is really to learn some techniques, things that you probably already learned in language arts, and remembering to transfer those skills into science class and really all of your classes. So you all were given a paper that says answering text-dependent questions. I'm going to be going through these techniques with you today and modeling some of that. So I'm going to model a lot of them, and then there's going to be a section that you're going to be doing on your own, and then you will be answering questions on your own. And hopefully the results will be better than what I originally received with the B article because you're using these techniques. So the first technique on here is to preview the article. So everyone should be on this paper following along with me so that you can see what we're doing. So the first thing you're going to do is you're going to look for and read headings of the entire article, look at pictures and browse captions, look for bold-faced terms or larger print that stands out, and then after looking at all those, you're going to make an inference based on the above items on what the article is about. So let's look at what the article is for today. So you should all have received a copy of the article From Stem Cell to Any Cell. So we're going to just quickly preview the article together. So again, do this with me so that your hard copy in front of you, you can see at the same time what I'm doing. So here's our title, From Stem Cell to Any Cell. It's done in 2005 in October. It's broken up into nice little organized paragraphs for us. We've got a picture at the bottom here, caption. Says these images show human embryonic stem cells. We're going to come back to this word embryonic. Not sure exactly what this is about yet. Look on the back. Looks like we've got, again, nice broken up paragraph. Looks like here we've got a separate little bold-faced title, Living Better. So this must be about living better, something to do with that. Let's look on here in this picture. Looks like we've got, again, embryonic stem cells. So keep looking at these terms, embryonic stem cells. It must be part of what the article is about. Different cell types. We've got gut cells, neural cells, bone marrow, cartilage. Looks like a bunch of different types of cells. And that's where the article ends. Okay. So I'm going to make an inference that it's obviously about cells, stem cells in particular, and has something to do with embryonic. So I see the word embryo in there, so probably something to do with a baby, I don't know. So that's my inference so far. All right. The next piece is to preview the questions. Okay, we want to read through the questions before reading the article, circle or underline key terms or phrases the questions are asking, and then keep a mental note of these questions while reading. So the questions that you're going to be answering are actually on the back of this paper here. So we're going to flip it over together and circle or underline key terms. Now again, remember, when I'm doing this, this is what works for me. It might look different for you specifically, but I'm modeling how it might look. So flipping it over, I'll see what the questions are. So first question, what is a stem cell? I'm going to circle the word what, and then stem cell. That's a fairly short, easy question, but I want to make sure I'm focusing on what, and specifically we're talking about a stem cell. What are two possible uses for stem cells? Give specific examples from the text. So I want to make sure that I do definitely write two when I'm answering this question. I'm going to be looking at uses of the stem cell, and I want to make sure that I give specific examples from the text. Where do stem cells come from? So here I'm looking for where specifically and where they're coming from. Number 4, use evidence from the text to support the statement on page 3. The goal of the stem cell research is to help people live better. So definitely want to underline evidence here from the text, and then I want to support my answer with the statement from page 3. So I'm going to circle that so I make sure I go back to page 3 to find this statement so I can best answer that question. Okay, so that was previewing the question. Okay, the next technique is to annotate the article as you read. So underlining key ideas and making a comment about the idea, possibly a number or question that it pertains to. Circle words that you don't know the meaning of, and after finishing a few sentences surrounded by the word, try and use context clues to write down what it means. So again, I'm going to model this and annotate a little bit for you, but I'm going to leave part of the article undone so that you can try it yourself after seeing my own technique. And there's no right or wrong way, but this is, again, just a sample of what that might look like for the annotation. So I'd like you to annotate along with me so that you have the model right on your papers. When you're off on your own, you could refer back to the way that I did it. Okay, so let's do this together. I'm not going to talk as if I'm speaking to you. I'm just going to read it as if I were reading it in my head and what kind of annotations I would make as I read. From stem cell to any cell, that's our title. The search is on for ways to use stem cells to treat injuries and cure diseases. Looks like it's 2005, so it's outdated, not completely up to date. For maybe a day, about 9 months before you were born, you were just one cell. Then you were 2 identical cells, then you were 4, then 8. Okay, so it looks like here we're talking about 1 cell, 2, 4, 8. We're talking about cell division here. Since then, you've grown into a complicated organism with many trillions of cells grouped into specialized tissues and organs. The cells in your brain do the thinking, the cells in your heart pump blood, and the cells in your tongue let you taste food, and so on. Okay, so it sounds like we've heard that we're a complicated organism, 4 trillions of cells. So specialized, I've heard that in class. We were talking about cells that have certain functions, like the brain, thinking, cells in the heart, pumping the blood, the tongue takes food. All right, so it looks like, cells that do different things. In recent years, scientists have made an amazing discovery. Even though most cells have specific jobs, some primitive cells called stem cells exist in everybody's body. Stem cells are unspecialized cells that can develop into nearly any type of body cell. So the most cells, like the ones they were talking about up here, have specific jobs, but the primitive cells, I think that I've heard that before. Primitive means early, I think. So that's called stem cells. They exist in everyone's body. So it looks like the stem cells, they're unspecialized. So they will not have a specific job. So they would be different from these guys. Okay, that can develop into nearly any type of body cell. So they can develop into any body cell. So maybe they can be like these. So this looks like this answers that question, what are they? So I'm going to come back here and think when I answer that. All right. So that picture again was how human embryonic stem cell colonies are grown. So this must be what stem cells look like. Embryos, babies in the earliest stages of growth before they are born, have stem cells. Certain tissues in adults also contain stem cells, although the range of cells into which they can develop is limited. So there's that word embryos again. So talking about babies in the earliest stages of growth. So early stages of growth, that's what an embryo is. And that's where they have stem cells. So maybe that's answering the question of where they come from. Okay. So it also says certain tissues in adults contain the stem cells. All right. So in 1998, scientists at the University of Wisconsin-Madison figured out how to collect human embryonic stem cells and make them grow. Since then, researchers have learned to mix stem cells with combinations of proteins called growth factors to make the cells grow into different types of cells. Now the search is on for ways to use stem cells to treat injuries and cure diseases. So it looks like they're collecting these embryonic stem cells. I'm going to do a little side note that I'm talking about babies here. That's where they're coming from. And they're growing them and mixing those with proteins and some growth factors. And that's what's helping them develop into these different types of cells. So they can treat injuries, cure diseases. So looks like the basic gist here is that stem cells can be made into different cells. For example, stem cells could be extracted, turned into new bone cells, and then injected into weak or broken bones. Or they could become nerve cells that would heal spinal cord injuries, skin cells that could replace badly burned skin, or brain cells that could help people who have suffered brain damage. The possibilities are endless. It looks like this is really about how the ways stem cells can help people. So we have new bone cells for broken bones, nerve cells for spinal cord injuries, skin cells for badly burned skin, and brain cells for people with brain damage. So pretty impressive, all those things it can do. So at this point, the ability to create all the different types of cells in the body has been pretty much proven to be real through Gary Friedman. He's director of the Center for Regenerative Medicine in Morristown, New Jersey. All the focus now is on getting new cells to behave the way we want them to and go where we want them to go. So it looks like ability to create different cells in the body is pretty much proven, but this here talking about where they need to go means that looks like we need some more research needed on this topic. Okay, so that's all I'm going to sample for you as far as annotation. The Living Better piece, you're going to now try these techniques out on your own. But let's look at the one last technique, which is to finally answer the question. So refer back to the text to answer the question. Typically, questions start from information in the beginning of the article and follow the order of the text. The beginning of the text would be a good place to look for the same answer to number 1, and the end of the text would be a good place to look for the answer to the last question. So this isn't always the case, but it's a good starting place at least where you can start to look for the order of things. And most of the time that will be the case, but like I said, it doesn't always go that way. So I would like you to really use these techniques anytime you're having to read an article and answer questions, and you're going to continue to use the techniques for this last little section, Living Better. And what your job is going to be after you finish annotating is you're going to come back to the questions and do your best to answer them. So remember, I'm looking to see how well you're able to answer them based on the text that you read using those techniques. So really do a nice job, your best job that you can, and we'll discuss it soon after you're completed.